Alright guys, so on this first one, what's the first step? Yeah, because there's nothing I can simplify on either side. So now I start moving numbers and letters. All my letters are together already. This is what's out of place. I want to put that over there with the other numbers. So then I get 2x equals 6. Yeah, you almost always divide last. So I get x equals 3. And if you plug it back in, twice 3 is 6, plus 3 is 9. Check. So if I say check your answer, I need to see the check happening, right? If you don't show me the check happening, you'll lose points. That sucks a lot. Now here, there's actually two things you could do first. Well, I think most of you guys probably distributed the 2. Mm-hmm. Did anybody notice you could divide the 2 right off the bat? And then get the 11 there, so you would actually get the same answer. But let's do it this way. So if you multiply the 2 in, you get 4x minus 10. And that was a lot like that did to begin with, right? What's out of place?
The 10.
The 10's out of place. It's over there with the letters. It should be over on the other side. So of course you're going to do what?
Plus 10.
Yeah, plus 10. And just always, it's going to sound kind of silly, but I see people doing this a lot because they say the 10, I got to subtract 10, but I'm like, how would that cancel? Make sure what you're doing is actually canceling what you're trying to cancel.
Moving it over.
Oh, yeah.
I don't know.
Yeah, you try to figure it out. So here you get 4x
equals 32.
Equals 32. I like it. And then, of course, divide by 4. X equals 8. So if you put an 8 in, you get 16 minus 5 is 11 times 2 is 22. Check. I like it.
Can you do the other one?
Oh, yeah. So if I would have divided by 2 first, it would have done this. This would have become 11, right? So I'd have 2x minus 5 equals 11. Add the 5, I get 16. Divide by 2, I get 8. Because I have twice something is 22. So that something has to be 11. So you can always step back and look at it less algebraically and more just numerically. Well, whatever number this is, it's got to be 11. Because when you double it, you get 22.
But this is algebra, so we have to see algebra.
Well, you can be creative with it, right? I like it. Nothing wrong with that. Okay. So over there, the very first thing your eyes should be drawn to, distribute. You're always looking for distribution, so you can free up all those parts so they're able to go together with other things. So you get 3 plus 10.
Negative 5.
Good. Minus 5x. By the way, I always get somebody that tells me this is 8. What would you say to that person that put an 8 here and then multiplied it?
Yeah, that's not helpful right now.
Huh?
Just tell them it's not helpful right now.
It's not helpful? But why are they wrong? Because 3 plus 5 is 8. What do you want from me?
You have to do the order of operations.
Order operations. And order operation says 5 is multiplying. It's got to be done first. The 3 plus, I don't know yet. Now I know what that is. Now I can add 3 in. Minus 4 equals negative 6. So now here I can do 3 plus 10, 13 minus 4, 9.
Minus 9.
Beautiful. The 9 is positive. So people key in and that's a subtraction here, but I could have written it negative 5x plus 9. So again, whatever operation you use has to cancel what it is you don't want. I don't want the positive 9, so I got to subtract 9.
That's what you do once I do.
Exactly. And of course, hopefully, I haven't said that yet, but hopefully, I think all of you guys are used to that by now. But in order to maintain balance, if I only change to one side, then it's not the same equation anymore, right? And you always, people like to use like the scale. If you take some weight off of this side, it's going to go. You got to take the same amount of weight off of that side. I kind of hate that, but if it works, great. Wow. So you get negative 5x equals
15. Negative 15.
negative 15.
Yep.
And then
Divide by 5.
yeah, what would you tell this person?
Divide by negative 5. Oh, we're not adding.
But why not? He's not good enough. He's like, yes, I am. I'm adding.
5 is the 5 X's. So
Yeah, what's the operation here?
multiplication.
Will addition cancel multiplication?
No.
Hell no. That's not what you say. And I'll say that on your test or whatever. I'll say addition can't cancel multiplication. What the hell? Maybe I won't say what the hell, but. All right, so you divide by the thing that's multiplying by x, which is -5. So you get x equals
3.
3. Kick ass. So if you plug a 3 in, 2 minus 3 is -1. Times 5 is -5. 3 minus 5 is -2. Minus 4 is -6. Yay! Okay, maybe. All right, we're almost to the freaky one. So again, here your eye should go straight to this distribution there. And this one here, of course here you got to be careful when you get -2x plus 14i. So then you get 9 minus 10x equals, good, -x plus 18. Cool. And now you almost always, for some problems like this, you're going to get to a point where you have numbers, letters. Now you just choose a side to take the letters to. Now you could add x, but see how the x's would still be negative. So a lot of you guys might have done that. I would do it so that my variable ends up positive, so don't make a negative mistake. So I would say add 10x. So I get 9 equals 9x plus 18.
Alright.
That's right.
Okay.
It's -9. You minus 18 from
Yeah, good. So you subtract 18 now. Get them over there. So you get -9 equals 9x. And then you just,
It's -1.
good, divide by 9. Almost always divide last. So you get x equals -1. And if you plug a -1 back in, it should work out. Real quick, before we tackle that last freaky one. By the way, the answer to number 5 is not 9. Watch. It's not undefined either. You gotta be careful. X equals 3. What does it really mean when I get to this point? What does this mean? It means that when this is true, then this is true. You with me? So, watch this real quick before I do that last one. One place equations could come from is somewhere like this, a little bit of a silly place. Instead of trying to destroy an asteroid before we all die, it could be, is there a number that is one more than itself? Now do you guys see how that equation represents what I just said? Is there a number? Okay, I don't know what the number is, I'm going to call it x. That is equals one more than itself. Now, just tell me, without even looking at that, is there a number that is one more than itself? Neat. What number is that? Please tell me. What number is one more than itself? So like 7 would have to equal 8. Or is there a number that does that?
No.
Please tell me no. If I add 1 to something, is it the same thing as what it used to be? No. Fundamentally, no. It's 1 bigger than what it used to be. There is no number that stays the same when you add 1 to it. So the answer to this should be no solution. There should be no way to make this work. There should be no number that solves this, that works. So if I try to solve it, minus x, I get 0 equals 1. This does not mean that I have proven that 0 is 1. Let me write a paper about it. When this is true, this is true. So is this ever true?
No.
So then this is never true. There you go. That's all. Just because I feed math an equation that has no solution doesn't mean that math has to be able to solve it then. Math is going to go, all right, if you can write that weird shit, I can say this. Nah. So it's the only way math has to say, whoa, dude, that was bogus. This is the only way math has to say that to us. Because thankfully math didn't have like a body in the mouth. I don't know what it was. This is the only way it can talk to us. It's like math's Ouija board. So again, let me catch up to what you guys did to this. Forget that poor little minus x, dude. Oh my gosh, okay. So then you got 2x minus x is x plus 8 equals, that's x plus 17, right? So you get your x's together. Don't try to save it. I love the people that are like, no, x, I'll save you. No, the x's are dead. They are dead. I always have people write this and then they put an x underneath it. Because they know, otherwise there's no x's. And they're like, but it's algebra, there's got to be an x. No, it doesn't got to be an x. Right? So I get 8 equals 17. Well, some of you guys also did this, and you got 0 equals 9. Or you just got 9 sitting there. There's no way you can start off with something that has 2 sides and then have a side just disappear. No, it becomes 0. So can 0 ever equal 9?
No.
No. So then there is no solution.
Ah,
I knew it was one of those.
Yeah, we reserve undefined for division by 0, a number that's not defined to do what I'm trying to make it do. This has got to be solve it. There is no solution. That's what you say.
And so for like the over numbers, I remember.
Oh, yeah.
It was like say 8 equals 8. That's all
Beautiful.
number. And then,
So, yeah.
I got you. And then the other one was I think I fit over number, no solution, and there was one more, I believe.
Well, the other one would be consistent. What's called the consistence equation. It actually has an answer, right? So yeah, if I would have gotten 9 equals 9, then it would have been all real numbers. Because when is 9 equal to 9? Always.
Yeah.
So then the answer would be all numbers. All real numbers would work. And what would that equation be like? Well, it'd be like, okay, what number, when I add 1 to it, I get 1 more than the number? Well, that's every freaking number. You understand? So if I solve this, I'll get 1 equals 1. Ooh. Right, people will circle that. No, if you circle that, you're going to lose some points because you got to tell me what the hell that means. That means the answer is all real numbers. All real numbers. All right, how do you guys feel about that? Some of that sound familiar, hopefully?
The same.
Huh?
Huh? Math is math.
Math is math is math is math is math. Sorry, I'm stealing the love is love is love is love. I think that's enough for today. Wow. I'll give us an early day today. Is that all right? Somebody feel upset? You want a refund for that? You're like, yeah, dude, let me out early and give me money. Shit.